Welcome to aminacademy.com. In physics, let us discuss about thermodynamics. Some introduction will do now. Thermodynamics is a branch of physics which deals with the energy and work of a system. It was born in the 19th century as scientists were first discovering how to build and operate steam engines. The thermodynamics deals only with the large scale response of a system which can observe and measure in experiment. This here the system is hot, heat is flow through that system and it arrives the cold area. After that, equilibrium achieved, then both bodies are same hotness. In physics, we need to define the motion of heat, temperature, work, etc. More carefully, more carefully, we have to measure all the things. Historically, it took a long time to arrive at the proper concept of heat. Before the modern picture, heat was regarded as the fine invisible fluid filling in the pores of a substance. Thermodynamics is the branch of physics that deals with the concept of heat and temperature and the interconversion of heat and other forms of energy. Thermodynamics is a macroscopic science. It deals with the bulk system and does not go into the molecular constitution of matter. In fact, its concept and laws were formulated in the 19th century before the molecular picture of matter was firmly established. Thermodynamic description involves relatively few macroscopic variables of the system, which are suggested by common sense and can be usually measured directly. The distinction between mechanics and thermodynamics is worth bearing in mind. In mechanics, our interest is in the motion of particles or bodies under the action of forces and torques. Thermodynamics is not concerned with the motion of a system as a whole. It is concerned with the internal macroscopic scale of the body. Now, for example, when a bullet is fired from a gun, what changes is the mechanical state of the bullet, its kinetic energy, in particular, not its temperature. When the bullet pierces a wood and stops, the kinetic energy of the bullet gets converted into heat, changing the temperature of the bullet and the surrounding layers of wood. Temperature is related to the energy of the internal, that is disordered motion of the bullet, not to the motion of the bullet as a whole. Now let us discuss about thermal equilibrium. Thermal equilibrium, that is, a system is said to be in thermal equilibrium when there is no temperature difference between the system and surroundings. Temperature, as you know, measure how hot or cold the body is with respect to a standard object. Here, look at this. One body is 0 degree Celsius, other body is 100 degrees Celsius. Both physically contact with what happened. The temperature from hotter body flow to the cold body and it achieve some temperature. It's called equilibrium temperature. That means 0 degree plus 100 degree without loss of temperature through the surroundings. It becomes, both bodies becomes 50 degree Celsius each. Yeah. Equilibrium in mechanics means that the net external force and torque on a system are zero. The term equilibrium in thermodynamics appears in the different context. We see the state of system is an equilibrium state if the macroscopic variables that characterize the system do not change in time. For example, a gas inside a closed rigid container completely insulated from its surroundings with fixed values of pressure, volume, temperature, mass, and composition that do not change with time is in a state of thermodynamic equilibrium. That means heat is not flow from inside to outside surrounding, or from outside surrounding it won't enter inside, as well as there is no changes in volume, temperature, mass, and composition of the constituent inside the cylinder is said to be in equilibrium, and it's called a thermodynamic equilibrium as well. In thermodynamic, an adiabatic wall between two thermodynamic systems does not allow heat or chemical substances to pass across it. In other words, there is no heat transfer or mass transfer. Here, this is an adiabatic wall. It won't allow heat from one surroundings to one system to other system. It's called a adiabatic wall. In theoretical investigation, it is sometimes assumed that one of the two systems is the surroundings of the other. Then it is assumed that the work transfer is reversible within the surroundings. But in thermodynamics, it is not assumed that the work transfer is reversible within the system. The assumption of a reversibility in the surroundings has the consequence that the quantity of work transferred is well defined by macroscopic variables in the surroundings. Accordingly, the surroundings are sometimes said to have a reversible work reservoir. Along with the idea of an adiabatic wall is that of an adiabatic enclosure. It is easily possible that a system has some boundary walls that are adiabatic and other that are not. When some are not adiabatic, then the system is not adiabatically enclosed. Though adiabatic transfer of energy as work can occur across the adiabatic walls. Now, in thermodynamics, a diathermal wall between two thermodynamic systems allows heat transfer. Here, we shown this is a adiabatic wall. It won't allow the heat transfer through the wall, but diathermic wall, it easily allows heat from one system to another. That is, heat transfer occur. The diathermal wall is important because in thermodynamics it is customary to assume a priori for a closed system the physical existence of a transfer of energy across a wall that is impermeable to matter, but it is not adiabatic. Transfer, which is called transfer of energy as heat, though it is not customary to label this assumption separately as an axiom or numbered law. Here, this is adiabatic wall means that heat flow it possible outside that system. It won't heat flow through inside system itself. That means here only outside that system can pass throughout. Heat can pass through outside of that system is called adiabatic wall. Diathermic wall or diabatic wall, that look at here, that heat energy can go inside through the wall and came out. So from that we can differentiate between adiabatic and diathermic wall. For further detail, we will discuss in future videos. We have done. Please subscribe our YouTube channel.